So I'm going to go through some tips in different areas that can help improve your performance. And then Urvashi is actually going to show you how you can do a lot less work and get more done and better, which I think is exciting. Right, so, okay, let's see what's there. So right now, we're going to talk about getting data in, getting data out, what tools you should use. I'm going to talk about, some schema design things like primary keys and indexes, parallel index creation, some configuration things that you can do or not do, how you look at memory and how you can get better performance on a Linux system with a different memory allocator. And then we'll look at queries and what's your workload like? Is it read-only? Is it what percentage of reads or writes do you have on things matters where you want to focus on how you set up your machine. And then the ugly duckling, and then she's going to tell you how machine learning can solve this for you and do a better job, quite honestly. So on importing the data, and I gotta see which slide. So for logical, okay. So the dumping, we used to have the MySQL dump, and it can dump a full instance and all that. But the MySQL shell, we've been replacing utilities that we had in the command line in the shell, and the shell can do things in parallel and much, much faster. And so it can also do things like working with the object storage systems and things like that. And so it's really a much better option. So, dump is an old tool. It's a serialized tool. It's not very fast, and it's on the command line. And with the utilities inside of the shell, you can automate things. You can check errors, all sorts of things. So you get the option of using JavaScript or Python to check things out. So, use that. So on the import side too, right? So it's one thing to dump it, but then you got to load it, right? And so really can use this load dump utility, right? So it's an export and an import utility. Unlike dump, where you would export it and then you would run it with the SQL client to reload it, this will actually work off the things. And so it can do more things in parallel. It can break files apart. It can load multiple things at the same time. So it's really a better system for doing that. So this is going to make your moving data around much more pleasant. So another thing is that if you don't need durability, then you can turn off the redo log and you can load things much faster. So you can alter the instance, disable entity redo log, and then change these various global settings. And when you go to push the data in, it'll go very quickly. And a lot of times when you're doing these sort of things, you're not doing it in a case where you're doing it on some running database where you can't just, kill the table and redo it. It's a case where you can kill a table and redo it, reload data, things like that. If you're doing, some setup or test or QA or various things, right? So there's various use cases where you can do this. Now, obviously, on certain production systems, you may not want to do that. You need to make sure everything stays safe. All right, and I'm going kind of fast because I want to give Urvashi enough time. So in schema design, right, the primary keys are important. And you really need to pay attention in MySQL because, we have a clustered index with every InnoDB table, and you really want to have a good primary key. And so they're all the rows are stored with a clustered index. And then when you go back to get to the row, if you've created secondary indexes, right, they have a reference to the primary index. And so if your primary index is a bad way to get to the data, none of it's going to really run very fast. So you don't want to do that. So what you do want to do is you want to have a sequential key that goes into your primary index when you create, when you set up the table, and you don't want it to be like random. And so the problem is that if it's pretty random, you end up scanning through a lot of pages. So these pink blocks there are data access. That's not a good thing, right? That's a lot of page accesses. So the more page accesses you're doing, the slower it's going to be. On the other hand, if you have a sequential key, and whether you do that with auto increment or you have one of your own ways to doing that, then if you're touching pages with a nice sequentially ordered ID, you're going to have a lot less page accesses, right? A lot less pink there. So, page was touched, much better, far fewer IOPS. So another problem is that sometimes people don't pick a primary key. So we'll pick one for you, right? And we'll pick the one that's the first unique key, that's the first non-null unique value, right? We'll just do it. Well, that's not going to end up being a good choice a lot of the time, right? You shouldn't do that. And so we create these hidden primary keys as well. And the problem is that these you don't have any control over these sorts of things, right? And this, it's just a bad idea. So really, when you do your design, you really should think about what your primary key should be. You should try to make it a very serialized, sequentially increasing value. So if you want to look, so what tables don't have a key? It's very simple. Run this command. Oh, no keys on these tables. I need to go in and analyze what's wrong with them. So there's this GIPK mode, right? And we put this in because if you're doing HA, you need to have a primary, you need to have a key so that we can share things across the servers and such. And so this controls the creation of these invisible keys. And so when you're running there, it's there, it's hidden, it's called my row ID, right? So it's in there, so you can get to it. And this is, a lot of times these row IDs are good things to do if you need to go do data, get rid of it, duplicate data, things like that. So that's good to know. All right, so if you have created a lot of indexes, you may have, I know when I was a DBA, I would kind of overkill it if the database wasn't too big. But really, you don't want to have those. You don't want to maintain them. They slow down your insert rate because there's overhead in building these x-axis. So you can easily run in, look, see what's unused, find it out, and then drop these, right? So these are indexes that have never been used. They're using up space. I just need to kill them. The other problem is sometimes people create more than one index on the same thing. There's duplicates. And so we don't stop you from doing that. There may have been some reason you were doing that, and you need to get rid of them. And so you run that query. Oh, there's my duplicates. Drop those indexes. So you can also, if you're not sure that you want to drop an index, or if you're not sure that it's going to make a difference in your performance, you can actually sort of disable them. And so given that some indexes take quite a bit of time to build, a lot of overhead and those sort of things, you can set these as invisible, leave it that way for a while, right? If there's no performance degradation, then you know that it's safe to drop it. So this is sort of a safety fallback mechanism. But if your performance all of a sudden crashes, then you can just go in and re-enable them, and they're there, and they were maintained, and you're not losing the value that they had. So this is just a way to watch things, right? So I did this alter statement, I did this big index, what's going on, and how long is it going to take, and when's it going to finish, all that sort of thing. So we've really tried to expose more data when you're doing these DDL things like alter statements, creating indexes and such. We'll also see if we have missing indexes. So the most common way to look is that you look for full table scans. I've got a full table scan. That's a bad thing, right? It's scanning billions of rows. I'm obviously missing an index there, right? So that's really a bad thing. And so now I can go in and I can run and look and see what that statement is that's causing that full table scan. And then I can see that it's going off of age or things like that. And I know that I need to add an index on that thing so that the where clause can grab it. That looks like something a machine learning thing could spot, right? And in the case if you've got thousands of tables, or we got one customer that has like 1 million tables. I don't know how you can have 1 million tables, but they do. So this is not something a DBA or a person can do. This is not something you can do by hand. Also, index creation can be very slow, right? And so you can actually change the settings to make it run in more parallel and give it more resources. So you can alter this table, right, in the default settings, and it took 9 minutes, right? That's kind of long. And I've got 4 DDL threads. I've got a buffer size, right? So maybe that's not enough. Right, 9 minutes isn't so good. So I can look and see how many CPUs I have. And based on that, I can determine, okay, let's see how we can set up those settings so I can do an index faster. And so based on the scene I had 16, I'm going to put in 8 DDL threads, 8 parallel threads, and based on the system size, I'm going to increase my buffer so that I can knock this out quicker. And then I can, of course, set it back later. And now it's 2 minutes, right? So 4 times improvement, that's pretty good. Yeah. All right, so number 6, I'm trying to get to her. She's got the fun stuff. So configuration, right? So there's a lot of variables, but probably the most important is the NAB buffer pool. And it's important to have the right size of memory set up for your database. And so this lovely query will tell you, buffer pool size, buffer pool percentage full, and buffer pool dirty, right? So based on those values, I'm going to go in and I'm going to size the buffer pool. So I'm also going to look at how many reads I got, how many writes I've got, and things like that. So that all goes into it as well. So you want to set those things up. And I think I hit a slide I probably shouldn't have hit on that one. So redo log, some people, we often just set it up way too big. And so the recommendation, I think, is that you look at how much you're using on an hourly or per minute basis, and really you want to be able to cover about an hour. And so we have 1.24 gigabytes there, and we're going to change our redo log capacity to that. So that's sort of a good rule, heuristic to use in setting your redo log size, and that's how you can check your database to do it. All right, so this is an interesting one, the InnoDB dedicated server. So if you don't want to do any of that, we will heuristically set up values based on how much memory you have on the system to configure InnoDB. And we're pretty close to giving you really good values. Now, what you have to be careful on is that when we say dedicated server, we mean dedicated server. And so if you go and throw other processes on there and you've got this setting, then you're probably going to have too much memory allocated for the server. But if it's a dedicated server, this works quite well. And especially when you get into larger server sizes, larger RAM sizes, which is typically maybe where you really have your production databases. All right, so the 7th thing, how much memory? I'm going to limit it. Right, so you want to have a warm buffer pool, right? So in case you do a restart, it doesn't take too long, right? And you want to set up, dump the buffer pool at shutdown, load it at startup. But you also want to, you can use that to get the buffer pool memory allocation side, right? So we can go in, we can look and see how much we've got there. And so that way you get these details, you see how much allocation you have there for all your memory, so InnoDB, all these sorts of things. And you can sort of use that to try to decide how to configure. So on the memory allocation side, if you're running a Linux, by default, most of them have JE-malloc. And it's good for performance, but it's not very RAM efficient. And so we run TC-malloc. It's our recommended choice. And so it's really fairly easy to install this on a Linux system with yum install. You make these changes on the LD preload in our environment, and you reload it in the system. And you can see in this case that, it's really much more efficient on how much RAM we're using, like by a lot, right? And so Dimitri, our performance expert, says there's just no reason not to run TC-malloc. So 9, I'm getting to you pretty quick here. So about queries, right? So, you need to know your workload, and you need to know what its characteristics are. And so you need to know it maybe at the whole database level, but you also need to sort of know on a per schema basis. And so if you're sharing a server or something like that, then it's very easy to see, okay, what's the reads and writes on a schema or on a table, and sort of go from there, right? So 10, ugly duckling. So usually there's one really bad query, right? And so this is the what's my really bad query SQL. And we've got this thing, it's taken 4 hours. I mean, that's just crazy, right? And so what's wrong with that thing? So, I must have skipped another slide, I didn't mean to. So this will tell you who your biggest loser is. And my next slide that I hid was the results that showed you, oh, it's this table, it's doing a full table scan. So with that, right, do you really want to do all that across thousands of servers? I don't want to do that. I want to use machine learning. And so here we go.
Thanks, Mike. Hi, everyone. My name is Urvashi, and I'm part of the MySQL Autopilot team. So MySQL Autopilot uses machine learning to automate and optimize various aspects of the system lifecycle. So we have system setup, data load, query execution, and failure handling. So I've listed a bunch of the different features that we have, and there's a mix of OLTP and OLAP features. The ones highlighted are OLTP features. Today I'm going to talk about autopilot indexing. So autopilot indexing, it recommends creating missing indexes. It goes through the workload. Based on the queries in the workload, it finds missing indexes, recommends creating those, and also dropping any unused or duplicate indexes. So we have been talking about indexes a lot, and there's this balance that needs to be that we need to find the right balance of indexes, right? So if you have too many indexes, you have a storage cost, and you have it impacts the DML performance, because now you need to update those extra indexes as well. So the right performance is low. If you create too few indexes, if you have fewer indexes than needed, then you're impacting the select performance. So if your select queries become slower, you don't have enough indexes. So there's this balance that we need to find. So how does autopilot do that? We use machine learning. The machine learning models predict the performance impact of creating indexes without actually creating them. These models have been trained to predict the query and DML performance impact of the indexes. And they also recommend, so we also facilitate creating the indexes by giving the DDLs to create and drop the indexes. So as I mentioned, it provides, it predicts the performance impact of these indexes. So we are able to also provide that estimate to the users. So we can predict, provide a performance prediction on a query level and on a workload level. It also provides a storage prediction. So how much the indexes would impact the footprint. And also in the end, it provides the explanation. So what are the most affected queries by the recommendations. So I'll come to an example next, but just to give a few advantages of using machine learning here. One very obvious one is that there's no guesswork. We just train the models offline, and these models are able to take away all the guesswork and trial and error because we don't need to create indexes and try to validate what the performance impact is. They're customized to the individual workload. So based on the workload, the recommendations are generated, and it provides interpretability as well. The second point is really important here because now if you change the shape or if you upgrade the server version, then the underlying performance characteristics might change. Since these ML models are trained on a wide variety of data sets, they are able to adapt to these changes for you. And also, since we are trying to optimize for various targets, machine learning models help with that. We are trying to optimize for throughput, so we need high throughput, low latency, and also keep the storage cost minimal. So here's an example of the console. We have a couple of create index recommendations. We have a couple of drop index recommendations as well, and it gives the reason. So for create, it's obvious that it's a missing index. For drop, it also tells you if it's an unused index or a duplicate index. And also in the bottom, you can see that it's providing the performance and storage impact of these recommendations. If you click the button on the top which says show affected queries, it shows a list of the queries that are most impacted by these recommendations, and also provides estimate for the speed up for each of these queries. So you can actually make sense of the recommendations and confirm them. So we did this, we ran the autopilot indexing advisor on a bunch of benchmarks, and here are some results. So the blue bar here, they are representing just taking the benchmark workloads and running the queries with whatever indexes it came with. In the red one, we dropped those indexes and asked the autopilot to generate recommendations. With those generated indexes, we see that the performance is at par and even better in some cases. So with fewer indexes, it's able to match the performance of these manually hand-tuned indexes. I have a demo in the end. I'll have to click play, I guess, on the laptop. I'm not sure how it would be. So it needs to be. Do you have your laptop? So we're while we figure that out. So we're running a workload, benchmark workload here. On the bottom left, it's showing like it has a mix of transactions. And on the top left, it's plotting the performance of the workload, so throughput in terms of requests per second. So now we are refreshing. We hit refresh, we get recommendations. We get 3 missing index recommendations, 2 drop recommendations, and also an estimate of the performance speed up and the storage impact. You don't have to take these recommendations just as is. You can see the show affected queries and make sure that the indexes make sense to you. So you look at the queries that are most impacted, look at the estimated speed up and the execution time and everything, and say, okay, this makes sense and I want to go ahead and apply them. So now you can actually go ahead and click on the apply recommendations. This in the background, it's creating the indexes for you and dropping the indexes for you. Now we should see, as expected, we should see the performance impacted by the throughput. Here we see that it goes up to from 50 to 150 requests per second by applying these indexes. So that's really cool. Now let's, in the second part of the demo, the last part, let's change the workload. We are going to change the workload mix and introduce another transaction into the mix. That has an impact on the workload. It will drop the throughput because it's not been tuned for that query. So here we see that the performance drops, the throughput goes down to 50 requests per second. Now let's refresh the Advisor now we see that, oh, there is a missing index, so we should have created this index. And also again, we have the speed up and the storage impact of this recommendation. So we can see that the advisor is able to pick up on these changes in the workload. Now let's apply the recommendations and see what happens with the throughput again. So again, it's creating the index in the background for us. And as expected, the performance goes back up to 150 requests per second. So it's automating all of these things. You could manually tune the workload and find the indexes, but you could also just use this cool tool that we have now. It's in limited availability, but it's going to be generally available soon. So if you're interested in trying it out, please reach out to us. And with that, thank you very much for listening.